Hi everyone. Let's start paper 4 of alternative to practical O-level chemistry, May-June 2024, variance 41. Let's see what we have in this paper. A student finds the concentration of dilute acid HA by titration. By the way, it is the general representation of an acid. And according to my lecture, this is basically monobasic acid because it donates only one hydrogen ion in aqueous medium. Because it contains only one hydrogen ion in the molecule, so it donates only one hydrogen ion in the aqueous medium. So technically it is a mono basic acid. The student adds 25 cm cube of aqueous sodium hydroxide to the conical flask. Obviously, I'm going to use pipette or volumetric pipette to measure this volume. All right. Add few drops of methyl orange indicator. Methyl orange in acid shows red color, and in alkali it shows yellow color. And in neutral solution, it shows orange color. All right. So conical flask has sodium hydroxide. So in conical flask, when we add few drops of methyl orange indicator, obviously it shows yellow color. So color before reaction, yellow. And color after reaction, red. So color observation is going to be yellow to red at the end point. Okay. Slowly add HA to the aqueous sodium hydroxide until methyl orange changes color, and that changes basically yellow to red. Record the volume of HA added. All right. Figure 1.1 shows the apparatus a student uses to measure 25 cm cube of aqueous sodium hydroxide. Obviously, this apparatus is going to be the measuring cylinder. So examiner is looking for its name. Straight away, measuring cylinder. And I believe measuring 25 cm cube through measuring cylinder is a source of error, because if volumetric pipette of 25 cm cube is already given, obviously हमें उससे करना चाहिए था measure. अगर हम measuring cylinder से कर रहे हैं तो obviously ये error consider किया जाएगा, source of error consider किया जाएगा. Now name a more suitable piece of apparatus to measure 25 cm cube of aqueous sodium hydroxide. Volumetric pipette. Okay. Figure 1.2 shows the apparatus used to determine the volume of HA at the end point of the experiment. Name the apparatus shown in figure 1.2. This apparatus is going to be the burette. Let me check what sort of value is given. This is 23. This is 23.1, 23.2, 23.3, 23.4, 23.5, and this one is 23.6. So this is 23.6 value, all right? 23.6 cm cube. Let's move on to the next page. The initial reading on this apparatus is 1 cm cube. Use figure 1.2 to determine the volume of HA used in the titration. So volume of HA we need to find out. Initial value is 1.0 cm cube and final value is 23.6 cm cube. Yeah, 23.6. So 23.6 minus 1.0 cm cube, it's going to be 22.6 cm cube. That's the volume of HA used in the titration. Okay. In the next part of the question, the student washes the apparatus in figure 1.2 before it is used. State the substance used to wash the apparatus. Obviously, in burette, we have HA. Okay. So obviously, burette needs to be rinsed through HA. Next, describe the color change of the methyl orange at the end point, yellow to red. That's the end of question number 1. Let's move on to the next question. A student investigates the reaction of 4 metals A, B, C, and D with aqueous copper to sulfate. 4 metals are all gray solids. Okay, gray solids. The students puts 25 cm cube of aqueous copper to sulfate into the beaker. Either I'll take the measuring cylinder, or either I'm going to use burette or pipette. Measuring cylinder or pipette can be used to measure this volume and measure its temperature. Obviously, in order to measure the temperature, I'm going to use thermometer. Record this temperature table 2.1. Add a sample of A to the aqueous copper to sulfate. If A is added into the copper to sulfate, obviously redox reaction takes place, which is also called displacement reaction. Because A is more reactive than copper, it's going to displace copper ions in the form of copper metal in this reaction. Stir the mixture. Why are we stirring the mixture? Mixture stir इसलिए कर रहे हैं क्योंकि यूनिफॉर्म डिस्ट्रीब्यूशन ऑफ हीट के लिए. Until there is no further increase in temperature, measure the highest temperature of the reaction mixture and record this temperature in the table. Observe any changes in the appearance of the mixture in the beaker. Oh yes. Obviously, copper sulfate has a blue solution. So when copper sulfate undergoes reaction, its blue color fades away. And obviously, copper metal is produced, so it has a pink brown solid. That's the observation. The results for D as shown. Let's read this. This is 20. This is 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So this is 21 degrees Celsius, right? So in D, I need to write 21.0 degrees Celsius because examiner ने 1 decimal place use किया तमाम values के लिए, okay? Now highest temperature for D is, let's read that, 50 तो ये हो गया, 51, 52, 53, and this is exactly between 53 and 54, which means this is going to be 0.5, so 53.5. All right. Let me take out the difference of both initial and highest temperature. 46 minus 24.5 is, oh my God. So it's going to be 21.5. All right. And 53.5 minus 21 is going to be 32.5. ओके, तो यहां से एक चीज मुझे पता चल गई, ये हाईएस्ट टेम्परेचर है and obviously this is going to be the lowest one. Okay, so the highest the temperature, the more reactive the metal is, which means A is more reactive. The lowest the temperature, the lower the reactive metal, which means B is less reactive. So हम यहां से conclusion कुछ ये ले लेते हैं, the higher the temperature change, the more reactive the metal is. Okay, that means A की reactivity सबसे ज्यादा, highest temperature change है, that is 49.5 डिग्री सेल्सियस. उससे कम आपके पास है C, its temperature change is 39.0. उससे कम है आपके पास D is 32.5, and the lowest and the less reactive metal is B, which is 21.5 degrees Celsius. Okay, let me copy this arrangement because I'm going to use this arrangement later on. Okay, state the value in table 2.1 which the student record in an incorrect degree of precision. Incorrect degree of precision. Okay, let me check. These are the 1 decimal place value, लेकिन ये 1 decimal place पे नहीं लिए. It has to be 20.00 cm cube or 20.0 cm cube, just like this. So let me write down 20. Okay, and obviously वो डिग्री सेल्सियस में होगा, तो डिग्री सेल्सियस. The temperature for D are shown in figure 2.1. Record these temperature in table 2.1. I did that. Calculate and record the temperature increase. I did that part already. Now the next part of the question is the equation for the reaction between B and aqueous copper sulfate is shown. Copper sulfate is blue solution. At the end of the experiment, the student observes a colorless solution, a gray solid, and a brown solid. Explain how these observations show that B is an excess in the reaction. तो जाहिर सी बात है, जो अनरिएक्टेड बी होगा वो बीकर के बॉटम में सेटल हुआ नजर आएगा आपको, क्योंकि जो भी चीज अनरिएक्ट एक्सेस अमाउंट के अंदर होती है वो बीकर के बॉटम में या फ्लास्क के बॉटम में सेटल हो जाती है. अनरिएक्टेड बी is seen in the bottom of beaker. Okay, using the equation in third, write the formula for the colorless solution. Obviously the colorless solution is BSO4 because aqueous medium है उसका. Gray solid is basically B and brown solid is basically copper. An examiner is looking for the formulas, so आप नाम नहीं लिख सकते. ओके, और हम यहाँ कोई एक स्पेसिफिक मेटल भी कंसिडर नहीं कर सकते बी की जगह पे. कुड बी एनी मेटल. सो आपने बी की टर्म में ही आंसर देना है. नेक्स्ट, use your results to arrange A, B, C and D in decreasing order of reactivity. तो यहाँ पर हम लिख देते हैं उस ऑर्डर को. ये आ गया ऑर्डर हमारे पास. मोस्ट रिएक्टिव इज A, उससे कम C, उससे कम D and सबसे least reactive is B. Explanation: the higher the temperature change, the more reactive the metal is. Okay. A student repeats the experiment using fifth metal. Fifth metal is represented by Q, let's suppose. Okay. This metal is the second most reactive of the five metals. Okay. So मैं क्या करता हूं, मैं इसको दोबारा से लिखता हूं यहां, and this time slight changes ये हैं कि second highest है Q. All right. Okay. What can I suggest the temperature increase for this experiment? Examiner is looking for a value actually. So this value should be greater than 39.0 and lower than 49.5. So you can suggest or you can write any value. Let's suppose I'm gonna write 42 degrees Celsius, okay? Or value should be between 49.5 degrees Celsius and 39.0 degrees Celsius, okay? Either you can write this statement or any suggest any value. The temperature increases measured are less than the true values for these experiments. So the temperature increases are technically lower than the actual value. Suggest a reason for this. Reason is heat loss from the top of the beaker. आप जानते हैं कि बीकर का जो टॉप है वो खुला हुआ होता है, तो जब रिएक्शन होगा एनर्जी रिलीज होगी, वो एनर्जी एस्केप कर जाएगी, जिसकी वजह से कैलकुलेटेड वैल्यू जो है वो ट्रू वैल्यू से कम आई है. सो इस सोर्स ऑफ एरर को न्यूट्रलाइज करने के लिए इंप्रूवमेंट क्या होनी चाहिए? यूज कवरलेट on top of the beaker. State and explain the effect of using half the concentration of aqueous copper to sulfate. If concentration is halved, amount of copper ions would also halve. If amount of copper ions would be halved, then obviously the temperature change would be half or decreases. Decreases. I mean to say temperature change or increase in temperature decreases. Explanation. As concentration is halved, amount of copper ions would also halved. As a result, increase in temperature decreases. Third question. A student does a series of experiment To investigate solution R, a student leaves wooden splint with one end dipped into R for 10 minutes. The student then placed damp end of the wooden splint into blue Bunsen burner flame. The flame briefly shows a shade of red and turns yellow. State two possible conclusion for this. So yellow shade confirms sodium ions. Sodium ions shows yellow color. And this red color shows either calcium ion or lithium ion. Both shows red color, okay? But I'm not sure which one is the correct one, calcium or lithium. So might be question में आगे चल के हमें ये confirmation हो कि इसमें से दोनों में से लेना कौन सा है. But इस वक्त तो ये दोनों possible है इस red की वजह से. Explain why it is difficult to make a definite conclusion. For the same reason, because both calcium ion and lithium ion shows same color. Okay, because different ions shows different color, but both these different ions shows same color, which is why it is very, very difficult to make the definite conclusion. The student adds dilute nitric acid to R followed by aqueous barium nitrate. Okay. The student concludes R does not contain sulfate ions. If sulfate ions is not present, obviously white precipitates will not appear. To state the observation which allows the student to make this conclusion. Obviously, if there is no precipitate, no change appear. Okay. Or you can write solution remains colorless because there will be no reaction. And I believe solution remains colorless is the most hot point for the examiner, because barium nitrate has a colorless solution. When you add nitric acid into it, it will remain colorless. When there is no sulfate ions, obviously you will not get a precipitate, which is why solution remains colorless. So this is going to be the most important point as compared to this one. Okay. The student adds dilute nitric acid to R followed by aqueous silver nitrate. The student observes white precipitate. When student observes white precipitates through silver nitrate, obviously conclusion is going to be chloride ion. The student adds aqueous silver nitrate to aqueous sodium carbonate. Okay. Silver nitrate has a formula of AgNO3. Sodium carbonate has a formula of Na2CO3. Sodium and nitrate, they will react together, converting into sodium nitrate. Silver and carbonate combine together to give silver carbonate. As a result, you will get white precipitates of silver carbonate and a colorless solution of NaNO3. Then add dilute nitric acid drop by drop until no further change is seen. White precipitates dissolve. I mean to say this silver carbonate is dissolved because silver carbonate is reacting with nitric acid, converting into silver nitrate plus water, and effervescence of carbon dioxide gas is given off. So white precipitates dissolve means silver carbonate dissolves and a colorless solution appear. So colorless solution जो है वो silver nitrate का भी है, water का भी है. Describe one other observation. Obviously, carbon dioxide gas is given off. So carbon dioxide shows effervescence. effervescence is observed. Suggest why it is important to add dilute nitric acid in C. Dilute nitric acid. Why are we adding dilute nitric acid in this scenario? Because डाइल्यूट नाइट्रिक एसिड हम क्यों ऐड कर रहे हैं? डाइल्यूट नाइट्रिक एसिड हम इसलिए ऐड कर रहे हैं ताकि जितनी इंप्योरिटीज होती हैं सिल्वर नाइट्रेट में इन द फॉर्म ऑफ कार्बोनेट आयंस वो न्यूट्रलाइज हो जाएं. To remove any impurities like carbonate from silver nitrate solution. आप ये भी कह सकते हैं to prevent the precipitation of silver nitrate we need to remove impurities, and for that we need to add dilute nitric acid. Okay, you can write that information also. The student adds a few drops of aqueous sodium hydroxide to R. Okay, state the observation the student makes which suggests R may contain calcium ion. Okay, so if R contain calcium ion and if we are adding sodium hydroxide in it, obviously we will get white precipitates. Now one white precipitates are formed. Since calcium ion is present in R, which means I'm not going to use lithium ion here. I'm going to use calcium ion. See? So that shows calcium ion. That's confirmed now. Describe what else the student needs to do to confirm that calcium ions are present. State what the student observes. What the student does at excess aqueous sodium hydroxide. Because before that, examiner were using few drops. Now I'm using excess amount. So in excess amount, white precipitates remains insoluble. The student warms the solution from E. The student concludes that ammonia gas is produced. State the observation the student makes which confirms that ammonia gas is produced. Oh. So ammonia is the alkaline gas and it changes damp red litmus paper into blue. Ammonia changes damp litmus paper into blue. Identify a cation other than calcium present in R. Obviously, it's going to be the ammonium ion. क्योंकि आपके पास R में NaOH ऑलरेडी था, आपने उस NaOH को हीट किया यानी उस सॉल्यूशन को, तो उसमें से अमोनिया गैस रिलीज हुई. So whenever any ammonium salt react with NaOH, always ammonia gas is given off, which means ammonium salt contain ammonium ions. Okay. Because ammonium salt gives ammonia when treated with NaOH. That's what we have done in the theory section also. Next, solution R is made from a mixture of two different ionic compounds. Suggest the name of these two compounds. The first one is calcium chloride, and the second one is ammonium chloride, I believe. Okay. Now the question is कि यहाँ पर सोडियम भी तो था, हमने सोडियम को क्यों नहीं यूज किया, सोडियम क्लोराइड क्यों नहीं लिखा? तो हमने सोडियम क्लोराइड इसलिए नहीं लिखा क्योंकि हम सोडियम आइंस को ऑलरेडी इन द फॉर्म ऑफ NaOH ऐड कर रहे थे, विच इज वाई हम सोडियम आइंस को नहीं लिखेंगे. ऑल्सो सोडियम आइंस की कोई ऑब्जर्वेशन होती भी नहीं है NaOH के थ्रू. ठीक है. So there's the end of question number 3. Let's move on to the next question. Let's see what we have. Barium carbonate decomposes when heated. So when you heat something, either you need boiling tube, or either you need crucible and lid. मेटल के चैप्टर में क्रूसिबल और लिड दोनों बताए मैंने आपको. Okay, so I'm going to use crucible and lid. Okay, the word equation for the reaction is shown. Okay, barium carbonate has a formula of BaCO3, barium oxide has a formula of BaO, carbon dioxide has a formula of CO2. Plan an experiment to determine the percentage loss in mass when barium carbonate is heated. Percentage loss in mass calculate करना है. So percentage loss in mass calculate करने के लिए हम mass lost इसको divide कर देंगे mass sample से into 100 कर लेंगे. So हमारे पास आंसर आ जाएगा. Your plan must include the use of common laboratory apparatus and sample of barium carbonate. Whew, okay, one more thing, guys. If we are heating it, obviously we need tongs to hold the crucible or boiling tube. We need gloves. We need goggles. Okay. And obviously we need to measure the mass lost and we need to measure the mass of sample. So we need electronic balance also. One more thing. Crucible needs to be placed on the tripod stand. और tripod stand जो होता है वो बीच में hollow होता है, so we need to put wire gauze in it. So these are the potential apparatus, common laboratory apparatus, which can be used for this decomposition. All right. कुछ और आएगा तो वो भी ऐड कर लेंगे हम इसमें. Examiner is looking for the apparatus needed, method to use, the measurement to take, procedure to ensure the percentage determined as accurate as possible. Measurement are used to determine the percentage loss in mass. You may draw diagram to help the answer. So अगर मैं one by one सबको देख लूं तो बहुत अच्छे से हो जाएगा. तो सबसे पहले एग्जामिनर हमसे apparatus मांग रहे हैं, so हम apparatus की हेडिंग लगाते हैं और यहां से apparatus को लिस्ट करके दे देते हैं. सबसे पहला है हमारे पास इलेक्ट्रॉनिक बैलेंस. Then we have wire gauze. Then we have tripod stand. Then we have crucible. And lead. Crucible and lead दोनों साथ इस्तेमाल होते हैं हमेशा. Okay. Tongs, क्योंकि हीटिंग होती है तो हमें टोंग्स भी चाहिए. और जाहिर सी बात है हमें मल्टीपल एक्सपेरिमेंट्स करने पड़ेंगे एज एक्यूरेट एज पॉसिबल के लिए. सो उसके लिए हम मास ऑफ सैंपल भी सेम रखेंगे और टेम्परेचर भी सेम रखेंगे. और टेम्परेचर सेम रखने के लिए हम यूज करेंगे हीट रेजिस्टेंट मैट. टेम्परेचर भी सेम रखना है, मास भी सेम रखना है, तो हीट रेजिस्टेंट मैट्स भी यूज करेंगे। ओके, दैट्स माय apparatus, दिस इज डन। मेथड के बाद है हमारे पास, सॉरी, apparatus के बाद है हमारे पास मेथड। और प्रोसीजर, तो इन दोनों को साथ लेके चलते हैं। लेट्स टॉक अबाउट प्रोसीजर। इसी प्रोसीजर के अंदर हम मेथड भी देख लेते हैं। सबसे पहले मैं क्रूसिबल और लिड को ड्राई करूंगा और क्लीन करूंगा। ड्राई एंड क्लीन द क्रूसिबल एंड लिड। आप चाहे पैराग्राफ की फॉर्म में भी लिख सकते हैं, चाहे बुलेट पॉइंट्स की फॉर्म में लिख सकते हैं, whatever suits you। इलेक्ट्रॉनिक बैलेंस यूज करके क्रूसिबल और लिड का मास वे करेंगे। वे क्रूसिबल, वे एम्प्टी, crucible and lead through electronic balance उसके बाद हम 2.0 ग्राम ऑफ बेरियम कार्बोनेट को ऐड करेंगे क्रूसिबल में। और फिर उसका मास वे करेंगे। So weigh the mass of crucible, lead and barium carbonate। इसको हम M2 से रिप्रेजेंट कर देते हैं इन ग्राम्स। ओके, calculate the initial mass of barium carbonate। तो हम इसको रिप्रेजेंट कर लेते हैं मास इनिशियल, और ये हो जाएगा M2 माइनस M1। और M1 वो था जब हमने क्रूसिबल को और लिड को क्लीन और ड्राई करने के बाद वे किया था। ठीक है, फर्स्ट हीट द क्रूसिबल जेंटली। Then heat it strongly for at least 10 to 20 minutes. After that, weigh the crucible lid and remaining solid. And that remaining solid must be barium oxide. That is going to be the residue. Record the mass. As M3 in gram. Determine the final mass. Of the residue, and that residue is basically barium oxide. How to calculate this mass? It's very simple. I need to find mass final, and for that I'm going to subtract M3 minus M1. Okay. For reliability of the experiment, reheat the crucible and reweigh until constant mass is observed. All right. On the basis of that, मैं यहां से लॉस्ट मास निकाल सकता हूं. So जो मास इनिशियल था उसको मैं सब्ट्रैक्ट कर दूंगा मास फाइनल से. So मेरे पास लॉस्ट मास आ जाएगा. On the basis of that, मैं परसेंटेज लॉस इन मास निकाल सकता हूं. और उसका फॉर्मूला मैंने दिया था कि लॉस इन मास divided by mass of sample into 100. I hope it makes sense to you. I hope you get the point. Yeah, how can we write such plans in this scenario? Okay, that's the end of this paper.